All right, guys, this is our third ed puzzle for radicals. And today we're going to talk about what we call rationalizing the denominator. Okay. So basically what that means is there's this unwritten rule in math that you cannot have a radical in the denominator. Okay, so we can't have a square root in the denominator. And if you don't remember, the denominator is the bottom of the fraction. Okay, so we have to take this and we have to get rid of it. Okay, now I'm going to show you 3 different methods to do it. You can choose the one that works best for you. Obviously, I have a favorite and I'll tell you which one's my favorite when we get there, but just because it's my favorite doesn't mean it has to be yours too. All right, so this is method number 1. And this is probably, this is going to result in the biggest numbers probably, but it's not really harder than any of the others, but it's definitely not a shortcut either. Okay, so when we're typically doing fractions, we know we can multiply anything by 1, and it doesn't change the value. Okay, so we can have, like if we have 2/5, we can multiply it by, I don't know, 12 over 12, because 12 over 12 is 1, right? And we'd get 24 over 60, which is the same thing as 2/5. Now, we normally write it as 2/5, but these are equivalent. Okay, so that's kind of the same thing we're going to do here. Okay, so I want to think about what is a number that I can multiply the denominator by that would make it so where I wouldn't have a fraction. Okay, so think of this. Anything under the square root that is squared, the square and the square root cancels out. Okay, so if I multiply this, guys, we don't care about what's on the outside, just what's under the radical. If we multiply this, not an equal sign, multiply it by a square root of 48 over square root of 48, we can do that because square root of 48 over square root of 48 is just 1. Okay, and what we'd get here is the square root of 15 times the square root of 48 over 4 times square root of 48 times square root of 48. Okay, and you're looking at me thinking, what the heck did you just do that for? I'll get there. So square root of 15 times 48, you just go in here, 15 times 48, we can put those together, over 4 times, well, isn't square root of 48 times square root of 48 the same thing as square root of 48 squared? Okay, and some of you, the light bulb's starting to go off. 15 times 48 is 720 over 4 times, guys, square root of 48 squared, we just talked about this. The square and the square root are inverses, so this just goes to 48. Okay, so square root of 720 over 4 times 48 is 192. Okay, now I've diverted our main issue, which is I got the square root out of the bottom. Okay, so mission accomplished, but we're still not done. Okay, now what I still have to do is I still have to simplify this fraction. So the first thing I need to do is I need to simplify this 720. Okay, so 720 goes into 3, 240 times, which goes into 3, 80 times, which goes into 5, 16 times, 2, 8 times, 2, 4 times, 2 twice, 2, 1, 1, you're done. Okay, so if I go back through and I pick my pairs, I have a pair of 2s, another pair of 2s, I don't have another 5, and a pair of 3s. So what I get here is 2 times 2 times 3 with a leftover 5. So 2 times 2 is 4. 4 times 3 is 12. Square root of 5. So that's what the square root of 720 is. So I can say this is 12 square root of 5 over 192. Woo! 192. Okay, which now, I'm not done yet. This can reduce more. 12 over 192 reduces to 1 over 16. So this could just be 1 square root of 5 over 16, which is just square root of 5 over 16. Okay, that is our final answer. That's probably the longest method to do it, but it's doable. All right, so a method, or a second method you can do this is method number 2 here, is before we just multiply square root of 48 over square root of 48, I'm going to simplify the square root of 48. And basically what this does is it keeps us, it keeps it from having to work with such large numbers. So 48 goes into 3 16 times, which goes into 2 8 times, 2 4 times, 2 twice, 2 1 you're done. So I have a pair of 2's and a pair of 2's and a leftover 3. So it'd be 2 times 2 square root of 3, which is just 4 square root of 3. Okay, so I'm going to rewrite this up here. Square root of 15 over 4 times 4 square root of 3. Okay, well, I can simplify this a little more. Square root of 15 over 16 square root of 3. Okay, now I still have a denominator that has a radical in it, so I have to get rid of this radical. But rather than multiplying by square root of 48, I can now just multiply by square root of 3. But remember, if I multiply it by square root of 3 on the bottom, I have to multiply by square root of 3 on the top so that it doesn't change the value of this. What I get is square root of 15 times square root of 3 over 16 times square root of 3 times square root of 3. Okay, well, this is just square root of 15 times 3. I can put those together over 16 times, well, square root of 3 times square root of 3 is the square root of 3 squared. Okay, square root of 45 over 16 times, well guys, square root of 3 squared, remember these are inverses, so these square and the square root cancel each other out, and I have 3. Okay, square root of 45 over, well, 16 times 3 is 48, I believe. Okay, now we're not done still. We have to simplify the square root of 45. Alright, so 45 goes into 5 9 times, goes into 3 3 times, goes into 3 once. Once we're done. Okay, pair of 3's, left over 5, so we have a 3 square root of 5. So I can change square root of 45 to 3 square root of 5 over 48. And then notice 3 over 48 reduces to 1 over 16, and I'm left with the square root of 5 still, which simplifies to square root of 5 over 16. Okay, so that's my second method. Alright guys, here's method 3 of 3. There may be other methods out there, and if you know another method, please feel free to use it. But this method here is the one that I prefer to use. And this is a good method to use if you're comfortable with factoring, or with factors, maybe I should say. Factoring kind of scares you off. So in other words, if I give you the number 24, it's easier for you to say, well, 24 is 1 times 24, or 2 times 12, or 3 times 8, or 4 times 6. And therefore, 1, 2, 3, 4, 6, 8, 12, and 24 are all factors of 24. Okay, so I'm going to think through this here. Okay, now, I know the factors of 15 are 5 and 3, so I could write square root of 15 as the square root of 5 times the square root of 3. Okay, this 4 isn't a big deal. I'm going to keep the 4. The 48 is what's killing us. So I'm going to ask myself, does 48, is either 3 or 5 a factor of 48? Okay, well, you should know that 3 is. okay, because 3 times 16 is 48. So I can change square root of 48 into square root of 3 times the square root of 16. Okay, some of you are wondering, why did you do that? This looks worse than before. Well, I did that because square root of 3 on top and square root of 3 on bottom cancel out. So I'm left with square root of 5 over 4 square root of 16. Okay, well, notice, what is the square root of 16? Okay, square root of 16 is 4. 4 square root of 16. So I can change that to 4. So square root of 5 over 4 times square root of 16 is 4, which then goes square root of 5 over 16. Okay, this method you can't always use, but when you can, as you can see, this is a lot less number of steps that we used here. All right, let's look at 95 together. Now, you can do whatever method you want. I'm going to go ahead and use my method if I can. I'll show you one here next where I can't, but this one I can. Okay, so just by playing around a little bit on my calculator, I learned that 392 can be found by taking 8 times 49. Okay, and while I'm intrigued with that, I like this 8 because I know that 48 is equal to 6 times 8. Okay, so I'm going to break these apart. So I'm going to say the top is 6 times 48. I'm going to change in a square root of 6 times the square root of 8. Okay, and then the 392, once again, I'm going to change into 8 times 49, so square root of 8 times the square root of 49. Now, this works in our favor big time because 8 and 8 go away. So I'm just left with 6 square root of 6 over square root of 49. Okay, well, you should know what the square root of 49 is. Square root of 49 is just 7 because 7 times 7 is 49. So 6 square root of 6 over 7. Here's my final answer. All right, I want you to try to do number 101 on your own. Now, 2 and 3 have no common factors other than 1, which doesn't help you. So you're going to have to use the longer way, but these are relatively small numbers, so it's not that bad. So go ahead and try this one on your own, and then we'll go over it. All right, if you did it correctly, you should have gotten 6 square root of 21. Okay, so what I did is these have no common factors, so I just have to multiply it, and it didn't simplify neither. So I just had to multiply both the numerator and the denominator by the square root of 3. Okay, so when I do that, I get square root of 2 times square root of 3 over 7 times square root of 3 times square root of 3. Well, square root of 2 times square root of 3 is square root of 6. And then I change this to square root of 3 squared. And the reason I did that is because the square and the square root cancel, so the bottom's just 7 times 3, which is 21.